So in order to demonstrate our object output stream and our object input stream, reading and writing to files in the form of objects. Now those aren't the only things you can read to and write. Read from and write to with this class. You can open up sockets, and you could write to a socket. You could write to either, oh gosh, my mind just totally went blank. There are the two kinds of sockets, communication. One does error handling, and the other one you're out of luck if it doesn't work. Like UDP versus TCP.
Yes.
Yeah, so both of those are classes that are implemented as object input streams and object output streams. So once you write an application that can save to a file, you could write an application that can communicate with something else just as easily. Of course, then you have to write the thing that it's going to communicate to. All right, so main is going to use our little class here. Just going to create an object. Person me is equal to Jeff. No, that doesn't work. What am I doing? I'm totally frazzled because of that Python thing. Person me is equal to new person. Me.name is equal to Jeff. No, wait. The way that's worded. Me.name equals Tarzan. There we go. Me.age is I have no idea how old Tarzan is, so we're going to say he's 39. By implementing the serializable class, what that means is serializing is writing it out to something or reading it back in from something, from a stream of bytes. And the cool thing is that just by adding that keyword, we get the magic of allowing it to be written out as a stream of bytes with an object output stream, or read it in as a stream of bytes from an object input stream. Usually if you do implements, then you have to go and you have to add some methods yourself. I haven't gone in to look to see what serializable actually is, that you don't have to do that. But it's cool. It's like, it's total gravy. You just add that to it, and all of a sudden you have the ability to write it out to an object file. So I'm going to create a file to save this data to. I'm going to say FileOutputStream. And I really should have already had all this. I'm going to call it FOS. Is equal to new file object stream, and I believe I can give it a name like object out.txt. The only reason I'm calling it txt, even though it's not a text file, is because I want to be able to go in and open it with Notepad without doing any rigmarole. Alrighty, I've totally botched that one because it's not offering me to import it. It's offering me to create the class. And whenever you click on something and it doesn't say import and instead it says create, that's a sign that you're off in the deep end on NetBeans and you shouldn't be doing that. Oh, no wonder it's FileOutputStream. Is equal to FileOutputStream. Now we get the import, right? Add import. Unreported exception. I'm going to wait to handle the exceptions at the end. Or I could enclose the whole thing in a try-catch block right away and then just catch all exceptions and then go back in and fix that later. But I think I'm just going to do it like this. I'm going to handle the exceptions later. Okay, so there's our our file output stream. Our object output stream needs to be created from that file output stream. Object output stream OOS is equal to new object output stream, and we pass our file handle into that. It's also wanting me to catch some exceptions. Now that I have my output stream, assuming that the file existed and I was able to create it and all that, I can write to it like this, OOS dot, and there's a whole bunch of write commands that you can use to write to an object stream. But the cool one, I mean, you can write a double, you can write an int, you can write a boolean, you could write a byte, which means that you could write this data out item by item. You know, I could write out the name, and then I could issue another write that would write out the age. And then, you know, if I had some other kind of data, I could issue a write there. But write object is the one that is really slick because you can write out an entire object. Now, the object I want to write is me. And then OOS.close, FOS.close. All right, now I'm going to try to add some exception handling to this. I should have put this in its own method so that I could use a cleaner way of doing this, but let's go ahead and go with this. So try opening the object output stream, and then try opening the object output stream, file output stream, and then the object output stream. I'm going to want to move these variable declarations to above the try statement so that they're available even when the try statement is done. The way I'm going to structure this is I'm going to do my opening in one try block, and then I'm going to do my writing in the second try block. So that's why I'm structuring it like this. You know, often you just include the whole thing in a great big try block. Okay, now it's complaining, rightfully so, that we don't have any catches. Well, I need to remember for myself what exception this guy was wanting me to catch. So why don't you tell me? It's wanting me to catch FileNotFoundException. That's reasonable. So down here, in my catch, FileNotFoundException EX. And I'm doing all sorts of nastiness that I shouldn't be doing, like I hard-coded the name of the file there, you know, but you know you're not supposed to do that. You know that that should be a string so that you could then report it. System.println could not open file plus the file name, which right now is ObjectOut.txt. See, I should have stored it in a string so I could just do that again. Now it wants an import for FileNotFoundException. Now ObjectOutputStream wants us to handle an exception as well. IOException. Well, we had to do that last time, I think, with the print writer. So we'll tack that on as well. Catch IOException EX. And since I don't know exactly what that is, I'm going to just print it out like that. Pretty much. IO error opening, you know, like that. Pretty vague. I could actually print the contents of the exception out with ex.text to get the text of the message out. Get message, I think it actually is. Well, let's find out after we add the import. Add import for Java IOException. So if I wanted to, I could do, you know, don't type this, ex dot, and you can get the message, or you could turn it into a string, or you could get the stack trace or whatever. You know, you can print out a lot of different things. Get message isn't a bad idea, but it's still a little bit too technical for the end user to see usually. Okay. So there we go. We have our file open by this time. I'm going to clean it up a little bit by, well, not clean, it's makes it harder to read, but I'm going to move those braces up so that I can get more text on the screen at the same time. And I want to move these variable declarations up out of the try loop, out of the try block. And the reason for that is just so that they're accessible once we leave try. I can set them equal to null if I so choose. I think by default all reference objects are set to null anyways as they are created. That's certainly true if they are a part of a class, or members of a class. I'm not sure if that's true in that case. Okay, so here we go. FOS is equal to new FileOutputStream. just like that. And then OOS is equal to new object output stream. Assuming all of that worked, we're good to go. We can write to the object output stream. But if we caught an error, we're not good to go. So in these kind of cases, what could I do? I could return out of it early. I could issue an exit statement. I'm trying to think of a really clean way of doing this. I think what I'm going to do, this may be tacky, is I'm going to create a Boolean flag called isOK. I'm going to set it to false. And if this line here, the opening of the object output stream, is successful, I'm going to set it equal to true. So that later I can check to see if that worked. If isOK, that means we actually successfully opened the file. I don't know why I didn't want to include this all in one giant try-catch block now that I'm thinking about it. I think the reason was I was originally planning on doing this inside of a method, and it's not a bad idea inside of a method that if you hit an error early on, just return out of it. You don't need to keep trying, to go deeper into the process if you're in a method. But we're in the main code here, and so just issuing a return kind of leaves a bad taste in my mouth because the program ends at that point. So if I'd made this a method, I would be sticking return statements after these errors. And you could pass out some kind of error code or something like that. Okay, so we have our object output stream. OOS dot write object and pass our me object into it. And again, it's going to want to throw an exception. I really think I made a mistake by not just doing this all at one gulp. You know what? It's not too late. Take that OOS write object.me and just replace that line that says isOK is equal to true. Because we already have an IOException handler right there, so we may as well do that right there. And then we could issue our closes right there as well. And by the time we issue all those closes and everything's great, we could, success. Object written to file. Now that should work. If I run it, I would expect to see it work. When I'm using FileOutputStream, I believe there's a second parameter which controls whether it will erase the file or append to it. And if I set that second parameter equal to false, it will erase the file each time. And so I'm going to go ahead and do that. So I modified FileOutputStream to have a second parameter, a Boolean value, which is set to false. False means overwrite file rather than append. Quite often you don't want to overwrite the file, but just for this demonstration I want to. Simplest example possible. Now we're getting some errors up here, probably about the assigned value is never used. What tough, I like seeing that equals null there. Makes me feel good. Okay. Build the project. Run it. Object written to file. Okay, great. Well, can I see that anywhere if I go over here and I look into whichever application folder I'm in? No, I'm not really seeing it in here. So I'm going to go use, Explorer to go find it. It's in my Documents NetBeans Projects directory. What I did to find the exact path is I just right-clicked on Java Application 14 or whatever yours was called, and then go to the project folder, highlight it, and hit Control-C to get that. And then I can pop open Explorer and paste that.
Yeah, mine's been written in Klingon and has musical notes.
Yeah, that's right. Okay, So here we go, object_output.txt. It's really not a text file, is it? You open it up, there we go. Not a text file. The only reason I made it have that extension is so it'd be easy to open with Notepad. There it is. But we see our name. We see Tarzan. And if we had chosen a very specific number, like maybe 65535, we might be able to see those FF bits out there. I'm going to do that. I'm going to change my age to 65535, hoping to see a couple of F's in the output, you know, in hexadecimal. I may not see them at all, but that's okay. I'm just kind of hoping. It's anything to help me make sense of what I'm looking at, because it is written in Klingon. Oh, cool. Really? It thinks it's a Unicode file now. I'm going to right click on it and choose like Notepad Plus or TextPad or something and see what it thinks. There we go. When I use TextPad, I right clicked on it and chose TextPad. I'm still not seeing anything that's recognizable to me other than that string Tarzan.
Actually, it gives you the program name. Mine's got April 20.
Yeah. It should give me the name of the class. I'm going to change that back to 39 because at least I could open that with Notepad. There we go. Java application 14 dot person. That's the name of the class that we used, and it uses that when we read it back in. And then we have two members. We have an age member and we have a name member. The name member consists of a string, so we get to see all of that. The age member, I don't know if that capital I means that it's an integer. You know what, I'm sorry to keep playing with this, but let's change public int age to a string. Public integer age. Not a string, but you know, a wrapper class. And then when we run it and we open it up, there we go. Part of it is specifying that it's got an integer as a member and it's got a string as a member. And then part of the data that's written out is in fact an integer. Java.lang.number is interesting. All numeric data types inherit from Java.lang.number, whose capabilities I'm not familiar with. Okay, so anyways, you can see why I said this is not real cross-compatible with other platforms. C++ would not know what a Java/lang/integer is. And like I said, somebody's probably written libraries that can open this and parse it and look, you know, for the numeric value and look for the strings and do stuff with it. Okay, before we write something that's going to read it out, instead of just writing out one person, let's create a couple of people and add them to an array list. So I'm going to create a couple more people. I guess 2 would do the point. You know, you, Jane, me, Tarzan. Okay, you dot name is equal to Jane. You dot age. She's the same age. No young ingenue is she. Alrighty, there we go. I want to create an array list that will contain both of those. Array list of person type, I'm just going to call it list, is equal to new array list, our normal syntax, and then add our 2 new members to it after we add our import statement. So list dot add me and list dot add you. And then down there in write object parentheses me, change that to our list. We're going to write the entire list out at once rather than just one object. So we could, you know, we could add a bunch of objects to this array list. and then flush them to file with a single call. I should make it print out the path to the file so that it'd be easier to open. I should also just quit closing the folder when I'm done with it. Alright, there it is. It's actually got two values in it. We see the name Tarzan and we see the name Jane. If we added more objects to the array list, we would see those names as well. Alright, I may have done that last bit a little too fast, so I'm going to leave that on the screen for a moment. But the next thing we're going to do is now we're going to write code that will open that file and reconstitute an array list based on that file. Okay, it's irking me that ObjectOutput.txt is hard-coded, so I'm going to change that to file name, and I'm going to create a string called file name and set it equal to my file. Because when we read our file in, we're going to need a file name as well. So adding some comments, write to the file using an object stream. And like I said before, you could write out individual bits of data. You don't have to do this idea of writing out, a lump sum object. You could write out integers, and doubles and stuff like that. But really, what you're doing in that case is you're writing out wrapper classes for an integer or a wrapper class for a double or whatever. So it's doing the same thing, but you're kind of picking and choosing individual bits of data to write out to it. Alrighty, our code's going to look very similar to this. I'm going to go down here after our last catch statement. Hopefully nothing wrong happened because it's kind of silly to open the file, but whatever. Like I said, these things should go in their own methods. We need a file input string and an object input stream. File input stream, FIS, is equal to new file input stream, and then specify our file name. If you made a file name variable, great. If not, just recreate the one you already had. And again, it's complaining it cannot find a symbol, so add the import for it. And it's also going to complain that we're not catching its exception. File not found. So unlike what I did last time, I'm going to go ahead and add the try and the catch right off the bat. So try, do all this, and then catch. You know what, I'm just going to copy these two things from up here, our other catches. Because I'm pretty sure that the things that can be thrown from this reading are the same things that can be thrown from this writing, with the addition of a couple of other things probably. So I'm going to copy those two lines and paste them down here after my try. That was a fast way for me to get this FileNotFoundException and this IOException in there. Now my braces are all messed up, so I'm just going to choose source, format, and try to clean them up. So my comment's going to be read from the object stream to get a new array list full of the data we just wrote out. And usually these would be two completely separate operations. You click save, you save the document, it writes your stuff out, and then later on you click load and it opens up the specified file. Okay, so we have file input stream here. Now we need an object input stream is equal to new object input stream and pass FIS, our file input stream handle, into it. Calling it a handle, you all know that that is a C++ term and I should be calling it a reference. It doesn't know what an object input stream is, so as long as I see import, I feel good about that. It's not complaining about any errors that it might catch, or that, that we haven't caught, probably because the second one that it wanted us to handle was IOException. Now we have the file open. We can read it in. But the thing about the read object method that we're just about to call is that it returns a reference to a generic object. Object is the superclass for everything else in Java. And then we're going to have to cast it into our specific object type, which in this case is an array list. So let's make it a new array list of people. I'm going to call it list2 to be real creative. Is equal to new array list. I don't even have to do this part. It just makes me feel good to have a reference already ready-made. But then the first thing we're going to do is blow right past that. And again, this object, this reference, should probably be declared outside the try block, but I'm going to leave it there for now. Now I want to assign the results of iis.read object into list2, but I have to cast it because this is returning a generic object, and until I cast it, Java does not know what kind of data is in that object. So this is an array list. We cast it to an array list. Illegal start of expression. Oh, because you don't use angle braces when you're casting. Use parentheses. And it's also complaining about another exception that we haven't caught yet. Class not found exception. Add a throw clause, or add a catch clause. I'm just going to add a catch clause to it. I'm going to make it a really generic error message. System.out.println. I guess I'm going to say class not found, even though that's not going to mean a darn thing to the user. That might be a case where if we printed out ex.getMessage, it might have a better error message than what I just put there. Okay, now we have the object. Let's close our files. iis.close. fis.close. Never again will I skip the closing step after what happened last week. Okay, and now let's print our object, our list out, our array list. We're going to need a for loop, For every person P that is in list2, system.out.print f %s for their name, %d for their age, /n. If I'd made a proper toString method, I wouldn't have to be going to all this trouble. P dot name, comma, P dot age. And then I'm going to print a done message, making me feel good that we got to this part. Now, whenever you start using this kind of stuff, NetBeans offers to turn it into a convert to try with resources. Go ahead and choose that and see what it looks like. The syntax for it's a little bit alien. It's got a nested try block, and inside the parentheses here is the object that you're creating that has to be closed and released when the try block is done. So it's kind of the same thing as adding a finally block that would close my FIS. FIS.close. I don't like that. I don't like the way it looks, but it's popular. So you can get used to doing that if you want. All right, I'm going to run it. I'm going to see if it prints out my data. And in fact, it did. the object was written from file, and although I didn't then have a message that said object read from file, which I should have, these print statements are inside this read code, not the write code. So we reconstituted this array list with a single call here by issuing IIS.readObject. If you wanted to, you could write out multiple instances of that array list. And then you could turn around and you could read in multiple instances of that array list. But you would have to eventually catch an end-of-file error. You might not have, more than one array list out there. You'd either have to know in advance how many array lists you were going to write. Yeah. Okay, so that is ObjectOutputStream and ObjectInputStream. I think before I print it out, I want to add a print line message that says that the object was read, just to make it, symmetrical with the output one. I've already forgotten what it says if you write it out. Object written to file. Okay, so after we issue our closes, I'm going to say object read from file. Okay. All right, and by making us type this in and making me type it in rather than just cut and paste, this took half the class time, unfortunately. So I don't think we will be able to finish the other thing that I wanted to do, but we can at least get a good start on it. Everybody get this working? If you didn't, if you're getting syntax errors, I do want to help you. All righty. Hope that makes sense. I guess I'll add a few notes up at the top using, okay. Object output stream, create file output stream, and then create object output stream. Using the FOS, and then call OOS.writeObject. Reading them is just the reverse. Using object input stream. You create your file input stream, your FIS, you create your object input stream, your OIS, and then you do my reference is equal to, and you have to cast it, class name, parentheses, OIS dot read object. So that's our cheat sheet, and obviously it's not that easy because we have to add a whole bunch of try catches. Cannot be cast to Java2 Person cannot be cast to ArrayList. That's because we wrote out a person, but we're reading in an ArrayList. Go back to your object, right? This is your input, so scroll back up into our object, right? And you, instead of writing out me, you write out our list. Not even list 2, it's the original list. Yep. Cool deal. Sure thing. Alrighty. The next, if I had any voice left, I'm not sure what happened. The next portion of this that I wanted to do, or the next thing I wanted to do today, was work on creating a GUI application. But I'm going to cheat and let NetBeans help create a jframe based application rather than rolling my own. And there are some advantages to doing that, which is that you can build a really nice looking application really quickly. But the disadvantages to that or that you don't learn as much about the Swing library as you would otherwise. But it's a good start. So rather than do what I had planned on doing, which is write an entire application that used the piggy bank class that we'd worked on previously, we're just going to start a new one, and it's going to do very, very little. But we'll see. So you can close all your windows. Then do File, New Project. I'm going to call this one JFrame Demo 1, implying that later on we may do a JFrame Demo 2. What have I done? Why do I know? Oh, for Pete's sake, I'm always typing that there. Yeah. All right. It's a Java application, but the difference is we do not want to create a main class. Deselect that create main class. If you don't do that, you're going to have to go and delete it anyways. And the reason for that is that the JFrame that we insert has a main method in and of itself. So we'll just depend upon that. Okay, so project name, JFrame demo, create main class is deselected. Now we have an empty project way down here at the bottom. Doesn't have a darn thing in it. Well, let's fix that. Go down to default package in your new freshly created project. If I create all of these, I'll be able to scroll it up to the top. Or not scroll it up, but nudge it up. There we go. Default package, new, and we want JFrame form. I could even just leave the name of it new JFrame. In my tutorials, I tend to just leave that. But you could give that, obviously a better name than that. My JFrame, whatever. And what it does is it comes up in a forms editor. Another drawback with doing it this way is that the forms editor you're using now is not compatible with Eclipse. So, this is NetBeans specific stuff. But the file that it creates, the Java source code that it creates, can be modified with any text editor or any Java editor. It's just that you will no longer have access to a frame, to a little GUI developer. Like, okay, let's make something that will add two values and put the results in a scrolling text field. So we're going to need two input fields and then a scrolling text field. The input field is the text field. So grab text field, not text area. That's the scrolling one that we're going to put at the bottom. So grab a text field and drag it out. It's going to be called text field 1. And I don't really know how to zoom in on this to make that clear. I'm sure that there's some zoom widget up there. Do that again. Grab the text field again and drag it out there. Then you have text field 1 and you have text field 2. Golly, that's impossible to see. See how badly things mess up once I change it to 800 by 600. Pretty bad, but there we go. There's our text field 1, our text field 2. We also have labels. Each one of these things that we're dragging out there is a separate swing control. And if you've ever looked at swing programming, you get the idea what that is. Each one is a class that you can create an object type of, and you can attach it to a panel or a frame. But this is going to do all that for us. We will go dig into the code to see how, but I want a label. So I'm going to grab the label control and put it over JTextField1. And I'm going to grab another label control and put it over JTextField2. And I want to edit those things so that they say something better than label 1 and label 2. So I'm going to right click on that label and choose edit text. And I don't know what I'm going to call this. Number 1. And I'm going to call this one number 2. Now presenting the user with a field that was pre-filled with that text is annoying, but I'm going to leave it like that for now. Then I'm going to drag a button out there. And then I'm going to drag a text area. This is a scrolling text area. However, the scroll bar does not appear until it actually has to. All right, now we have an application. It doesn't do anything, but when we run it, the very first thing it asks for is which class has the main method in it. Well, it's the jframe class that we just created. There, our application's done. We just earned our pay for the day. Okay, we're going to do something a little bit more. It's an empty application because it's not responding to any events that we generate. These controls can respond to a myriad number of events. I will demonstrate. For example, this text field, if I right-click on it and then choose Properties, you see Properties, and you can change the color of the button, you can change the text of the button there, whether it's horizontally aligned, and all that kind of nonsense. But you can also click over here on Events. Right now, we don't have any events bound to it, but we are going to, so that if the button is selected, it will call a method within our class. And we don't need to write that method first. We're going to let NetBeans add it when we double click on the button. So I'm going to close this now. We'll come back to that events later and see that it's been tied to a method. I'm going to come up, let's give this a better name than just JButton1. That's pretty annoying. So I'm going to right click up here and change variable name. Right now it's JButton1, but I think I'm going to call it JButton_add because it's my add button. You could call it anything you wanted to. You could call it Fred. That is the name of the variable in the code that represents that object. Now would be a good time to actually go into the source code. No, let's change the variable names for jtextfield1 and jtextfield2 as well. So I'm going to right click on jtextfield1 and change its variable name to jtextfield_input1. You don't have to create this JText field, but for now I like leaving it there because it makes it really easy to spot that it is a JText field. Later on I will give, variable names that did not have the name of the class embedded in the variable name. Same for jtextfield2. Change variable name to jtextfield_input2. Now, when I ran it, you notice that it had pre-filled these fields with that text that appeared there. You can change that text. Right-click it and do Edit Text. Just blank it out. Hit the backspace. Unfortunately, when you do that, it collapses the field. But you can uncollapse it. You can drag it back out. Do the same thing with jtextfield2. And we could fill these in with whatever starting values we wanted to. Since this is going to be adding two numbers together or something like that, I might want to put 0 and 0 in there. Edit the text, blank it out, put that back in there. And you know what I'm going to do? This is stupid and you don't need to do it, but I'm going to change the text for field 1 to say Fred, and I'm going to change the text for field 2 to say Barney, just so that when I look at the source code, it'll be real easy to spot those. All right, and a button that says JButton1 is pretty dumb. Its variable name is JButton_add, but that's not text that we want the user to see. So I'm going to right-click on that and edit the text of the button to just say add. Save it, build it, make sure I haven't horribly mangled it. It still doesn't do anything. We still don't have any events tied to any of the controls. But I want to go look at the source code. Notice that up here we're in the Design tab. There's also a History tab indicating changes that have been made to this file. But we want the source. I'm going to go look for the word add because I want to see every instance where our add button is used. So I'm going to do Control F and look for add. Notice that it does this. JButton_add dot set text, and it's setting the text. Now that's kind of odd. Where JButton_add come from? Well, the way these JFrames that NetBeans creates are structured is kind of odd. The variables, the members of the class are all listed underneath the methods. So when we scroll down, we'll actually see where jbuttonAdd is created. But here, this is being initialized with that text inside a method called initComponents. And this is all grayed out, implying that we should not be editing this. This is stuff that's under control of the NetBeans Forms editor, which is a little bit frustrating, but you learn to work around it. And like I said, it's better if you roll your own, but this is a good way to get one going really quickly, and you can get some ideas. So here we go. Set default close operation. That sets our window so it'll kill the program when the close button is clicked. There are other options there besides exit on close. Don't do this, but I'm just going to demonstrate. Oh, it's in the gray box, so I can't even change it. And then up above that, jTextField1 is equal to new jTextField. Input 2 is equal to new text field. Again, this is not where they're declared, but at least this is where they're being instantiated. JLabel1 is equal to new Java Swing label. JLabel2 is equal to new Java Screen. JButtonAdd is equal to a new Java Swing JButton. JButtonPane. The pane is the scrolling panel. And then the text area is the other part of the scrolling panel. So the scrolling panel of text that we're going to utilize is actually comprised of both of those objects. And so after all of those references are created with objects, their values are initialized. The text area is initialized to have 20 columns and 5 rows. And you can kind of look at, it's kind of ugly. It's not real easy to see what it's doing. All right, now we're out of there. Here's main. All main does, well, there's some stuff that we could expand and look at. Set the look and feel. If it would show that, it's not going to. But anyways, here's the meat of it. Create an event queue. Thread. And all that thread is a call to the run method. Or it actually creates a method called run, and then it invokes it. All right, now here's where we actually create our variables. Like I said, it creates our members underneath the methods of the class, which is kind of bizarre. I sure would like to see them up at the top, but there they are, all of our methods. Now let's make it do something. I'm going to go back into design, and I'm going to double click on this add button. Now I've added an event handler. It looks deceptive, like this is the only piece of it, but then if we go up and down and we find another reference to this, we'll see that this event listener is tagged to our button with a method called addActionListener. I'm calling them events, but they're actually I should use the term action. So here's the action listener for that button. The action performed, when it is performed, it will invoke this method, addActionPerformed. So I'm going to go back to where we were. I don't know where we were. I'm going to click over to design, double click on my button again, and it'll take me right back to where I was. So just to show that this is doing something, I'm going to put a system.out.println right here that says button clicked. Now this is stupid because it's going to be writing, to the default output, which the user will not see. But for us, it will prove that our button is handling this click. So I run it. There's my output window. When I click add, and output, it says button clicked. So our application is actually, like Frankenstein, it's coming to life. But we want it to obviously to do something better than that. We want it to get those variables out of the num1 and the num2 fields and add them together and then store the results of that in our scrolling output field. So firstly, let's worry about getting the values out of those input fields. And I've honestly forgotten what I called them, so I'm going to come back up here to change variable name and just copy the name of that variable. And then I'm going to go back into source. And so string I1 for input 1, or I guess I could call it S1 because it's a string at this point. String S1 is equal to jtextField underscore input 1. I just pasted that to make it easy. If you can't remember what it's called, do this dot jtextField and it'll narrow it down to your fields. So you can use the autocomplete in order to help find things. Now that's not enough. This is the control. It's not the text that's in the control. So we're going to use a method of this swing control, and we want to get text. Notice that there's other methods. Get the selected text. Get the tooltip text. Get the text at a specific offset going to a specific length. But we want the most generic one, which is just get text. Do the same thing, filling another string called S2. S2 is equal to this dot jtextField input 2 dot get text. And these look like horribly long things to type, but if you're using autocomplete, it's really easy. This dot jtext, that windows it down real quickly to your members of the class that match that file name. And when I said, this is when I named it jtextField underscore input 1 and jtextField underscore input 2, the reason I did that is just for this purpose. So when I type this dot and then I start typing jtextField, it pops up my variables. And if I just call them input 1 and input 2, I might not be able to find them that easily with the autocomplete. So that's just kind of a personal preference. Now we need to convert those to integers to double them, to add them, or to floats. Yeah, let's do doubles. Double D1 is equal to double dot parse double passing S1 into it. And then double D2 is equal to double dot parse double string 2. Now we can add them together. Double result is equal to D1 plus D2. And you can see that this isn't really copacetic. What we should be doing is using exception handling in case the parses fail, and then we could flash some error messages and stuff like that. And then let's just print our result. Because we've added a considerable amount of code, and I don't want to worry about filling that scrolling output field unless I'm sure that this is working so far. So I'm going to use printf. And my printf is going to say %f plus %f equals %f slash n. And into printf, I'm going to pass in D1, D2, and result. And again, that's not what we really wanted to do. We don't want to be sending output, to the standard error, to the standard output stream, system.out. But it will prove that it worked. So I run it. If I leave it Fred and Barney and I click add, it's going to blow up and generate an exception. However, each event you generate is handled by a separate thread. So that did not kill the entire application. If I click add again, I'm going to see another exception pop up. Now I'm going to type in some good data. 1.1 and 2.2 and click add. And I don't see that output, but if I scroll down here, eventually I should see where it says 1.1 plus 2.2 is equal to 3.3. So our application is working. It's kind of neat that it built something that is at least slightly thread safe. The exception doesn't kill it. The exception just happened in the thread that was created to handle this event. Now I mentioned handling the events. I should call it handling the action. Go back and design, find that button, right click on it, choose Properties, and then click Events, and you will see that one of them now has a value. I can't see it because it's Windows 2. Messed up. Yeah, but it's there. Action performed. I'm going to change my resolution again and hope that I can see it. I'm not seeing it at all. Yeah, let's do that. Property. Yeah, there it is, right there. J button, add action performed. If that's not what you wanted to do, you could clear it out. You could change the name of it. You could remove it completely, just by backspacing over it. I don't recall personally whether when you backspace over it, if it removes the method or not. So I'm not going to backspace over it. One slightly cool thing about using this tool is that just like when you refactor, it renames everything. If I decided I wanted to name this input field something different, and I did change variable name, don't necessarily do this, and instead of calling it input 1, I wanted to call it input A, then it changes all the references everywhere, even inside the action handler. It now says jtext field input a.getText. Okay, we have a whole 2 minutes left. Not sure I can code adding something to the scrolling text field in 2 minutes, but we can give it a shot. Yeah, we got to 8:20, right? Okay, cool. 7 minutes. So, private void add text. And I want to accept as a variable the string that we're wishing to add. Maybe 1000 by 768 would be enough. The first thing we want to do is get the text that's already in the object out. So I'm going to create a new variable, and I think I'll just call it current. I don't know what a good name for it is. String current is equal to, and now if I could remember the name of that object, it'd be great, but I don't, so I'm going to type this dot j text area 1 dot get text. We're going to get the text out of it. Now we want to add this new string to it. So current plus equals the new string, and then let's tack on a character turn, /n. I'm not sure that's big enough. This is actually taking less time than I expected it to, because this is going to work on the first shot. I am so confident. Alrighty. Now that we have our text, we can set the text of that JText area. And there are some niceties that we might need to worry about later, like making sure that it doesn't scroll to the bottom, when we didn't want it to. But doing it easily, this dot JText area 1 dot set text and set it back equal to that text that we extracted and then appended to. Now, if I had just done this to begin with, text area dot set text and passed in s, then it would only have one line in it. But instead, we're getting all the text of it out. We're adding some new text to it. Okay, so where we had our print statement, let's rejigger that a little bit so that it's a string.format rather than a printf. So I'm going to say string s is equal to string.format, and then the rest of the formatting is going to be the same. You know what? If I'm putting a slash in here, I don't need a slash in here. I need to decide how I want to handle that. I think I'm going to remove the slash in from the add text method. Okay, now we built our string, and we can call add text, passing it our new text as an argument. That text will be appended to the current contents of that field. Because we get the text out of that field, out of that text area, we append this to it, and then we set it again. Now we're ready to go. If I type in bad stuff, I'm not going to get anything good. But if I type in 1 and 2, and I click add, then down here I get a little message, 1 plus 2 is equal to 3. I keep clicking add, it starts filling up that text area. And the control is smart enough to start scrolling when it needs to. Now this is kind of tacky. So after looking at this, what I would do is I would expand it a little bit so that it wasn't scrolling left and right. That's really nasty looking. But there we go. We've written an application that takes in two numbers. And then just like a scrolling paper tape on an old-fashioned mechanical calculator, all right, that is it for this application. Let me create a Dropbox for those who got it working, and then I'll wander around for those who need help with it. Okay, if you refresh your Dropbox, you'll see an in-class assignment called in-class jframe. I'll give it a better name later.